Hey students, how you doing today? Mr. Elliott here. I'm back with my hat. I'm happy. Let's go ahead and get into our math. Yesterday we were learning about translations and quadratics, and that was dealing with the kind of the theoretical side of it. Today we're just going to work on examples, just working through examples, and I'm going to show you what type of work you need to show on a problem like this. If you see a problem, well, when you see problems like these on quizzes or tests. So I have 4 examples for you. I'm hoping to get through this lesson a little bit quicker than yesterday. So we're doing some translations and quadratics examples. And the first thing we're going to do is just dealing with translations. If you're given this graph here, and we're told to graph this equation here. So we're given f of x, and we're told that to graph g of x, and g of x consists of these translations of f of x. The skill that's needed in here is to be able to look at an equation and identify what translations or transformations are happening here. And one thing I said yesterday is that if it's happening outside the function, like this -4, that's going to control whether your graph goes up or down. So if you're going -4, it's going down, so your graph is going to go down 4. Then inside the function, I've always said, think of it one of 2 ways. You could either think on the outside you do the opposite of what they tell you to. No, sorry. On the outside you do exactly what they tell you to do. So on the inside you do the opposite. So when you think -2, you think to the left 2, but it's actually the opposite of that, so it would be to the right 2. That's actually not how I tend to think about it. When I look at this, I think, what number will allow the inside of this function to be 0? And it's 2. 2 minus 2 is 0, and 2 is the same. A positive 2 is the same as going right 2. So at that point, you just need to take your f of x, your the 3 main points, and we're going to travel down 4 and right 2. So my first main point, down 4, right 2. Second point, down 4, right 2. Third point, down 4, right 2. You have your 3 points then clearly labeled. Connect the dots, and be sure to label it that this is your g of x graph. That would be the technique if you were using graph paper. I also like doing these problems without graph paper. I talked in class or in my lesson yesterday about doing a coordinate analysis, what's happening to the coordinate x and coordinate y. Well, if you're going down 4, that means you're going to be subtracting 4 units from the y coordinate, and if you're traveling right 2, that means that you're going to be adding 2 coordinates to all the x coordinates. Then you would list off your coordinates. So I had the coordinate, going back to my f of x graph, I had the coordinate -3, 3, 5, the coordinate 0, 1, and the coordinate 2, 4. And if I apply this transformation onto these 3 coordinates, adding 2 to the x coordinates, so -3 would become -1, 0 would become 2, 2 would become 4. You're going to subtract 4 from all the y coordinates, so 5 minus 4 is 1. 1 minus 4 is -3, and 4 minus 4 is 0. And you know that the graph's going to look entirely the same, so you could just draw. I like to draw it first without drawing in the coordinates, and you just simply write them in. The 0, 1 point became 2, -3. The 2, 4 point became 4, 0. And the -3, 5 point became -1, 1. And that would be doing the exact same problem but without graph paper. And oh, I guess I should label it g of x, the good proper math. And if you compare the two graphs, they're the same. So you can do this problem using graph paper or without using graph paper. And that is equation to graph on translations. Second point of today is opposite, graph to equation on translations. So let me show you this problem. So it says, use the f of x graph from the previous problem and write an equation for h of x. So you need to be able to compare your h of x and f of x graphs. So let me actually unfold this paper. So I'm going to use my original f of x. And if I'm going to use my original f of x graph, I'm trying to zoom in here so it can be useful to you. One thing I'm noticing is that to get from this bottom point to this side point, it's going over 2 and up 3. And if I look at my h of x graph, it's also going over 2 and up 3. That lets me know that there's no dilations or reflections. Today it's only going to be translations. And I could really just look at the 0, 1 point, which would be right here, and see, well, how did it translate to get from this point to this point? And in this case, it's going down 3. And 1, 2, 3, 4, 5, right. And we're writing an equation for h of x. So h of x is, if I'm going down 3, that means that you took your original f of x equation, and because it went down 3, you subtracted 3, and that's outside the equation. And inside the equation, write 5. You'd always do the opposite. If you think write 5, I normally think adding 5. But it's inside, so we do the opposite, so it's x minus 5. Or think of it backwards, like if I plug a positive 5 into this equation, out pops 0. And that's exactly what I'm looking for. So that would be your h of x graph. I've typed up this writing equations for graph piece of paper, and I'm going to share this a lot with you. And whenever you're given in a graph, at this point, we haven't done any reflections or any dilations, so these wouldn't happen on these problems tonight. But when you identify the translations, if it's a vertical translation, up or down v units, you add or subtract outside of the function by that v. And that's exactly what I did. It was going down 3. So outside of the equation, I subtracted 3. If you're doing a horizontal translation, right or left h units, this is opposite. So instead of adding or subtracting, you'd be subtracting or adding by this distance of h. So in this particular case, because I was going right 5, I subtracted that number. So it was x minus 5. Okay, that was example 2. Example 3. Example 3 is, I have this, example 3 and example 4. Example 3 is going to be equation to graph, where I graph this equation right here. Example 4, I'm going to do basically an opposite problem where I'm given an equation, we have to graph it. But my next class is just about to get in here from eating their lunch, and I hate to, I didn't like it yesterday when they were interrupting the lesson. I felt bad for you guys and also for them. So I'm actually going to do this in a part 2 of a lesson, so check out part 2 for the next 2 examples. Thanks everybody, I'll talk to you soon.